Okay, everybody, let's take a look here at this problem. Pretty typical friction problem where I give you a couple of forces, a couple of masses, and then ask you to calculate the coefficient of kinetic friction. So let's go ahead and do this. The first step is going to be to draw a free body diagram for the object in question. And so what we're taking a look here is the sled is pulled at a constant speed with a force of 225 newtons. What is the coefficient of kinetic friction? So the object that we have the most information about is the sled. So let's go ahead and draw the free body diagram for that. So here's going to be my sled. Okay, and now since we know that the sled is on planet Earth, we know that the sled is going to have a force of gravity, so let's go ahead and figure that out. Now the important thing to realize with this is that the force of gravity is pulling down on the sled, but it's not just the mass of the sled at 100 kilograms. It's also the student that's riding in it at 55 kilograms. So if we put that together, the total mass of our object is actually 155 kilograms. So to go ahead and figure out the force of gravity, let's do that right now. All right, now since we know that the sled is sitting on the ground, it's not moving up or down, it must be in equilibrium with the ground. And so what that tells us is that the force of gravity of 1,519 newtons must be balanced out on the sled by the normal force pushing back up. And so because they told us the mass, and we know that the sled is not moving up or down, we also know that the normal force is equal to the same amount. Okay, so there's that. Now what we need to start doing is putting in the horizontal forces. So let's take a look. In the problem here, they tell us that the sled is pulled at a constant speed with a force of 225 newtons. So the four-wheeler there is pulling with the force of, and I made that way too long. Okay, we'd probably draw these if the weight was the way it was. We draw this much smaller here. So it's being pulled with a force of 225 newtons. Now that's our force applied. Well, how can we use that to figure out what's going on with the force of friction? Because we know that there's got to be some friction pulling backwards. In fact, that's what we need to go ahead and figure out for this problem. So what we have to do up here is take a look at the part where it says being pulled at a constant speed. If it's being pulled at a constant speed, the acceleration equals 0, which means the net force is equal to 0, which means in our case that the force applied is going to be equal to the force of friction. All right? So from this, we start to get in all the information we're going to need. So when it says what is the coefficient of kinetic friction, we now have enough information to start solving for that. We know that the force of friction on an object is going to be equal to the coefficient of friction multiplied by the normal force. All right? If we take a look here in this problem, we have all the information we need. We know the force of friction. It's the 225 newtons. We don't know coefficient. That's what we're looking for. And we know that the normal force from the problem before is 1,519 newtons. All right, so in this problem, we now know that the coefficient of kinetic friction is 0.148. Okay, here's the new problem. It says if another 35 kilogram child jumps on the sled, what would be the new force needed in order to maintain a constant speed? Well, now since there's more kids in the back, there's going to be more friction. So what is the four-wheeler going to have to pull with in order for this to happen? Let's go ahead. Let's just update our free body diagram from before. All right, so if we take a look at this problem, the additional mass of the other child is going to increase the force of gravity from the 1,500 roughly to 1,800. And now what that means is the normal force would also have to increase in order for the sled to stay on the ground and not go into it. The question now is there's still going to be a force of friction pushing backwards, and if it's maintaining a constant speed, that force of friction would be the same as the force applied by the snowmobile. Now the question is actually asking us for force applied, but in this problem, we know since it's maintaining a constant speed, the force applied is going to be the force of friction, and we know how to calculate force of friction. It's simply the coefficient of friction multiplied by the normal force. If you take a look here, we do have all that information, and so let's go ahead and calculate that out. Okay, the force of friction acting on the sled at this point would be 275.6 newtons. So in order to pull at a constant speed, the force applied would also now have to be increased to 275.6 newtons. All right, there you have it. That's a pretty simple or a pretty standard friction problem. If you have any questions, come see me during MLT or in class.